Hey everyone, and welcome back to the second video in the Kubernetes mini-series. In the last video, I gave you a high-level overview of what Kubernetes is, how I'm going to deploy it in this series, why you might want to get this in your home lab, and some of the benefits over an existing Docker setup. In this video, we're going to focus on the prerequisites, so that in the next video, we can actually deploy Kubernetes. So this video is going to focus on setting up all of the virtual machines that we need. And whilst that might sound straightforward, Jim, I know how to set up VMs, I'm going to show you how to do this with cloud templates using Cloud-Init and Ubuntu Cloud Images. This creates minimalist images, i.e. images with a low footprint for your machine, and they're also designed to be deployed in the cloud, which comes with a number of benefits. So when you start these machines, they will be automatically updated. They will include Cloud-Init features like having certificates baked into them, and you'll be able to clone a template to replicate this process over and over. That's right, it means that you don't have to go through the creation wizard each time. You can simply replicate a machine and it will spin up as though it's a new machine with its own MAC address, all the updates installed, and all the configuration taken care of. You won't need to go through any installation wizard. So let's jump straight into it and I'll get you up and running. So the first thing we want to do is to head over to the Ubuntu Cloud Images website. Now, when you reach this site, you'll see that there's a number of options. There'll be familiar things like Jammy and Luna, etc. And these are all the easy to remember names for the actual versions, which you can see over on the right here. The current LTS, that's the long-term service, i.e. the one that's going to be supported for 5 years, is 22.04, which is known as Jammy. Now, you could choose that if you wanted to, and that's going to give you 5 years of support. I think there's something like 2 or 3 years left on that. But I'm going to choose Lunar for this video because Lunar 2304 comes with the kernel 6.2, which comes with a number of benefits. For me specifically, that includes the Intel Arc drivers. And as you know from previous videos, I use an Intel Arc A380, and that does all the things like transcoding within my home lab. So go ahead and choose the distribution that's right for you. And when you go into the folder, again, you've got a few more options which complicate things. I'm going to choose the current version, so click on the current folder. And within this subdirectory, you want to choose the right image. What's the right image, I hear you ask? Well, traditionally, you would probably go for something like the cloud image amd64.img. And this is basically the one that is an image of Ubuntu, typically for bare metal installations. Now, this is a cloud image, so it's probably going to be virtualized. And handily, there is a KVM image, which you can see up here. So this is the KVM optimized image, i.e. it's designed to run in the kernel virtual machine. Proxmox uses the kernel virtual machine, so this is the image that we're going to download. And you can see that there's a very slight size difference, and that's typically because the kernel's stripped down because it's running in a virtualized environment. So it doesn't need to have all of the bells and whistles that you would need on a bare metal installation. So rather than clicking this to initiate the download, we want to right click it and we want to copy the link address. Once you've copied this link address, head into Proxmox. Now, as you know, I'm running a 2-node Proxmox cluster. That's 2 physical machines in the same cluster to give me that high availability across physical machines. But don't worry if you don't have that. You can still set up Kubernetes on a single Proxmox instance. So once you're on your Proxmox host, you want to click on your local storage. Now, you'll see when you click on local storage, you have the option of ISO images. You want to click on download from a URL, and then you want to right click and you want to paste the image that we just copied from the Ubuntu Cloud Image page. Click the query URL, it's going to go away and get that. You can see that it's 717 megs and we just want to hit download. So that's going to go away in the background now and initiate that download sequence. I'm going to let that complete and I'll see you on the other side. Once that's completed, let's just scroll down. Yep, task okay. So we're good to move on to the next stage. Now, traditionally, you would hit the Create VM button and go through this wizard. But we're going to need to use the command line to get this up and running. But don't worry, I'll talk you through each step, and there aren't too many. So over on your Proxmox host, we want to click on the shell. Now that we're in the shell, there's a few commands that we need to create. And if you've been watching my previous videos, you'll have seen me do this before, but now we're adding VM templates into the mix. So there's a few new concepts. So the first command that we need to run is qm create a number dash dash memory a number dash dash core a number dash dash name dash dash net and then the bridge. So what does this mean? Well, qm is what's going to create it, so it's a command we need to call. We're going to tell it to create a new virtual machine, and we're going to give it the ID of 5000. Over on the left, you can see all of these numbers here. Those relate to the IDs of those specific virtual machines. This is going to create a new one with the ID of 5000. It's going to have 2 gigabytes of memory. It's going to have 2 cores. It's going to be called Ubuntu Cloud, and the network 0, i.e. the default network interface, is going to be virtual IO, and it's going to be a bridge on VMBR 0. And if you remember back to my existing videos, you know that the VMBR 0 is typically your default LAN port. It's usually the one that Proxmox will be running on. So you need to tweak these to your setup, but the format, the syntax of this command will be the same. And don't worry if you make a mistake here. You can change this later before we convert it into a template. So when I hit return on this command, you'll see now on the left hand side it's going to update, and you can see now that we have the 5000 here. So that's great, everything's worked as expected. On to the next command. So the next command that we want to run is cd change directory /var/lib vz template, and the clue's in the last bit, ISO. Yeah, that's right, this is where we just downloaded that Luna cloud image. So if we hit return, and then if we do an ls, we'll see that the Luna Server Cloud Image AMD64 image is there. And that's exactly the same as if we look through the folder browser, like we just did in Proxmox. So now we're in this position, we're able to specify this image and mount it into the VM we just created. Remember, that's the 5000. Unfortunately, there's not an easy way to import a disk through the GUI, as far as I'm aware. So we need to do this through the command line. And that's really simple. So to do that, we run the following command. Again, it's a qm, and the command this time is to import a disk, because the disk is here. And we're going to import it to 5000. Remember, 5000 is the one that we just created over here. And the image, Luna, is this one here. And the important bit is the bit on the end. Now, NVMe is my storage that I have for all of my virtual machines. You will probably have local-LVM here. But if you're not and you're using an NVMe drive and you've given it a different name, just specify the name here. Remember, this is just the name where it's going to store it. So this will be bespoke to your setup. So when I hit return, it's going to go ahead and import that image into the virtual machine. Now that's completed, so we're on to the next command. So let me just clear the screen so we can see the next command clearly. So what we're doing here is we're going to say set 5000, that's the virtual machine we just created, and we're going to set SCSI 0 to be the disk we just created on our NVMe storage. Again, this will be changed to whatever your storage pool is. So when we hit return, that's now set the boot device for this virtual machine. Next, we get onto the important stuff. And this is where we first use Cloud-Init. So in this command, again, we're setting the virtual machine we just created, IDE 2, and we're setting Cloud-Init, and it's going to store it on my NVMe drive again. But what's this actually doing? Well, it's creating a CD drive on that virtual machine mounted to IDE 2. So when we create this, and we'll have a look in a minute in the GUI to confirm this, but there should now be a CD drive that says Cloud-Init on it. And you can see that that's been created successfully. Next, we're going to set it in the boot options to use that SCSI 0 drive. You can see that with the -- boot disk. And finally, there's one last command. Now, technically this one is optional, but I recommend you put it in. And it's basically to create a serial port on your virtual machine so that you'll be able to log in through VNC in Proxmox and interact with your virtual machine. This is a great failsafe just in case your networking goes wrong and you can't SSH into that machine. So we're going to create a new serial port of type VGA. And now that's completed, and you'll be happy to know we can leave the CLI now. So now that we've done that, let's click on our virtual machine on the left, and let's go into the hardware section. Here you can see that it's got 2 gigs of RAM, it's got 2 processor cores, it's got a SCSI controller, we've mounted the Cloud-Init drive, and you can see it's a CD-ROM, and it's got the drive that we specified, and it's defaulted to 3.5 gigs. The network device is there and it's on VMBR0 and it's generated a MAC address for us. And there's also a serial port there so we can connect through VNC. That's looking good. Now you can go ahead and configure this as you wish. I recommend an absolute minimum of 2 GB of RAM, otherwise you'll probably get into issues whilst you're installing Ubuntu itself. Typically I edit this and I'll give it 4 gigs, so 4096, and I don't want it to balloon, so I want it to be static. You'll need this in case you're doing any hardware pass-through anyway, because you can't have a ballooning device with hardware pass-through. So I'm going to OK that. And I also like to give it more than 2 cores. So typically, because I've got multi-socket, I'll give it 2 sockets, 2 cores. I'll make it NUMA aware so it knows how to distribute that across the physical cores, and I'll change the actual CPU type to be host. Now that's important because it will get all of the instruction sets and capabilities of the host processor rather than using a virtualized setup. So once I click OK, that should be reflected here. Also with this drive, you might want to edit it and give it SSD emulation. I do this because mine are on NVMe drives or SSDs and they understand trim. So basically it can go back and reclaim unused space. Really handy. If you're using NVMe drives or SSDs, I recommend you turn this on. You'll see that we've now got SSD equals 1. The rest of it you don't really need to change. Just make sure that your network device is on the adapter you expect, and take a note of the MAC address because you might want to reserve this in your DHCP for static IP addresses. That's something I definitely recommend you go and do. Moving on, we want to get into the Cloud-Init. So what's Cloud-Init? Well, the clue's in the title. Cloud initialization. So this is going to initialize this virtual machine with some set parameters, and you specify those here. So you're going to specify a default username. So I'm going to change this to be Ubuntu because that's the one I use in most of my videos, and hit return. I think it might actually do Ubuntu as the default anyway, but I like to specify it just in case. I'm going to give it a password, even though we're going to be using SSH to connect to this and we're going to do some certificates in a minute, but I'm going to put a password in here. I'm going to leave the DNS to be what the host settings are because my Proxmox host is set up correctly to my internal DNS providers. The next bit is the public keys. So this is really cool because it optimizes the deployment process. Probably with your existing setup, you're having to go in each time you create a new virtual machine and put your keys in there. No, we don't need to do that anymore. Cloud-Init is going to make sure that every VM we create using this template has that same certificate and it's deployed automatically. So as soon as you hit launch and it's downloaded the updates, you should be able to log in without any additional configuration. So you need to click on here and click edit, and then you need to paste in your SSH keys. Now you can either generate new SSH keys or you can use the ones that are generated by Proxmox. I'm going to use the ones that are generated by Proxmox, so that means that I can seamlessly connect via the console in Proxmox using VNC into this virtual machine. So here I've added the public key that's associated with my Proxmox and I hit OK. And now you can see that I can log in using Proxmox with this SSH key. You'll want to download this key as well to make sure that you can log in via things like PuTTY or WinSCP. The next thing you'll see is upgrade packages is set to yes. Now this is a really cool feature because when you deploy this machine, you're not going to have to log in and do a sudo apt upgrade and install, all that kind of stuff. It's going to automatically update this machine. So I'm going to leave that as yes. And each time you reboot the machine, it should also go and pull the latest updates, which is amazing. The last bit I want to do is I want to edit the IP config, and I'm going to set it to DHCP. Now you don't want to set this to static because each time you clone this machine, it would give it the same IP. So what I recommend you do is in your DHCP leases in your firewall, you take the MAC address from your hardware, i.e. here, this will be randomly generated each time, and you create a reservation in your DHCP and you specify the IP in that place, not on the host itself. Now, don't be too hasty. Do not click start this virtual machine. There's one really important step that we need to do before we do that, and that is to right click and convert this to a template. If you go ahead and start this virtual machine now, it's going to create that virtual machine, obviously, but the issue with that is it's going to generate things like its unique identifier. And then if you make a template from that, it's just going to copy the machine that exists, and it won't regenerate things like its unique identifier, MAC addresses, and all of that stuff. So you need to clone this before you start the virtual machine. Then, after you've created a template, every machine that you create will be randomly generated as a new machine, i.e. it's got a new seed. So let's click convert this to a template. Yes. It'll take a few seconds, and now it's done. And now you'll see that you can't connect to this, i.e. there's no console, you can't click start. That's because it's a template. So how do you make this work? Well, you right click it and you click clone. Now you want to make sure that you change this from a linked clone to a full clone. That will create a full VM that's not linked back to this template. Then you just give it a name. So I'm going to call mine test K3S 01. And I'm going to create 5 of these virtual machines. So I click clone, and now you should see a new virtual machine created here on the left. And you do. It's ID 112. So if I click ID 112 now, you'll see that it's got all of those Cloud-Init variables specified, and you'll see that the hardware is exactly as I set up. So let's create another 4, because I'm going to use 5 in this test deployment in the next video. And there you go. That is as simple as it is to create 5 virtual machines automatically. Now let's get onto the beauty of this. Click on one of these virtual machines and we're going to launch it. So I'm going to start with number 1, and I'll talk you through all the benefits now of using this model over your previous model. So when we click start, we're not going to have to go through the Ubuntu install wizard. You can see it's using that serial 0 there, and that's the reason we specified it, so we can connect through the terminal and view this in real time. And it's automatically going to deploy with those Cloud-Init variables we specified. So it's going to set things like the user, it's going to set the password, it's going to set the SSH key so we can connect to this afterwards. And as you can see on screen, this is the really cool part, it's automatically pulling all of the updates. So you know that when you start this image, it's already the latest version of Ubuntu. Now this usually only takes a few seconds to install. And typically at this point, you want to just hit return and refresh the screen because it's actually finished in the background. So there we go. I can now log in with my username and the password that I specified in the Cloud-Init. And hopefully we're logged in. And it's really as simple as that. So now if you go and grab your SSH key, you can use any of your existing terminals or WinSCP, for example, and connect to this IP. I do recommend you go and make sure that this is static in your DHCP lease, or you want to specify it within the network settings within this virtual machine. And there you go. I'm presented with the usual thing, yes, and then I should see the default folder structure within the home directory. That's right. And if I click on PuTTY, you can now see that I'm logged in as well. So everything's working. And if I do an IPA, I should get the exact same one. Yep, there we go. I've got the same IP address that I just connected to here. Perfect. So now you can go ahead and complete this process for all of these virtual machines. So just start them up, get them updated, make sure all of those DHCP leases are set to static or however you want to do that. Just make sure that the IP addresses are going to remain constant because that's going to be crucial for your Kubernetes deployment. You could technically do this using DNS names and resolving it that way, so it wouldn't matter so much what the IP address is, but I do recommend that you have static IP addresses to begin with. So that pretty much concludes the prerequisites we need for Kubernetes. Now, you could go and create all of those manually, but I'm trying to get you into that Kubernetes cloud mindset where we want to try and automate as much of this stuff as possible, not only for speed, but also to reduce things like human error. So now with cloud templates, from now on, you can right click and just clone that existing template, and you know that you're going to get an up-to-date minimalist Ubuntu image every time you do it that's unique, which is an awesome thing to have. Now for some added extras, you might want to go ahead and put your Kubernetes VMs on their own VLAN, but I'm not going to cover that in this video. It doesn't strictly matter, but if you want to be more security minded and restrict access, you might want to go and do that. Now, in the next video, it's the bit that you've been waiting for. We're going to get onto the actual deployment of K3S using KubeSpray. And I've just alluded to Cloud-Init being sort of semi-automation. We're going to take that a step further in the next video because KubeSpray is using Ansible under the hood to automate again a lot of the manual processes that you would typically need to do if you're manually configuring, say, Kubernetes IE K8s. The important bit is we've got the virtual machines ready and we've got the static IP addresses, so we can configure all of that readily in the next video. So go ahead, get your VM set up, and soon we'll be doing K3s deployment using our virtual machines. Please hit that like and subscribe button and drop a comment in the comments below. Take care everybody, and I'll see you on the next video.